we will study a very important concept of data structures known as linked list. Linked list is very important as it helps us analyze how the data can be added, deleted or inserted in the real world applications when we implement data structures using any programming language. So to start with, what are linked lists? Linked list stores data with structures, create a new place to store data. It is written using a struct definition that contains variable holding information about something and that has a pointer to a structure of its same type. Each of these individual struct in the list is commonly known as a node or the list which is created or the element of the list. Now, this is the terminology which is used when we work with data structures implementing linked list. Node, the structure combination of data and its link to the next structure is called a node. As you see over here, this is a complete structure which is created. It has a data and a link, and these two combined together is known as a node. This data can be used or given any other name, and this link can be given any other name. For the importance of data structure and linked list, I have given it a name link. It can be even called next or a pointer or whatever way reference you want to use it while writing the code. Address stores the address of the next node of the list. Pointer, a data type used to point to the address of the next node. Information, the data stored in the data field of the linked list structure. So information is whatever will be stored in this data part, and pointer will be this link to which it will be pointing to the next structure of the type node, that is this complete node, and address will be as it points to the next node, it stores the address of the next node. Now, next, the link points to the next node of the linked list. Now here if you see, we have two structures, data and next. So this is one node and this is another node. So what does next do? Next is that link which points to the node. In the previous one I said we used link, we can even use next. So here the next is pointing to the next node. Null pointer signifies the end of the linked list. When the next or the link pointer points to null, that means the linked list has ended. An empty list signifies no data in the linked list. So if the linked list is empty, there won't be any data and next in that particular structure of the linked list. Now these are the terminologies which are compiled together in a form of a table. Node, a linked list is a collection of number of nodes. Address field in the node, address field in node is used to keep the address of the next node, and data field in node, data field in node is used to hold the data inside the linked list. Now let's see how to create a linked list or how to create a node in the linked list. In this particular tutorial we'll be seeing how a linked list is created, how we can add an element or add a node at the end of a linked list and then print the complete linked list. So to create a node in the beginning of the linked list, the first thing we do is we create a structure declaration for the linked list. This is how my structure will be declared. Struct node, int data, struct node, pointer next. When I say this, then what happens? You will see that structure is created. For this structure, this particular node is created. So this whole thing is known as a node. And when I say int data, so this is my data field, and struct node pointer next, this is my next pointer field. So when we say struct node, this particular structure is created in the memory. And now we start with int main, writing the program. Curly brace start struct node pointer root. So this is where my variable will be used, as node is a complete structure. So when I am creating and referring in my program, root will be used. When I say root is equal to struct node pointer malloc, size of struct node. Malloc is a dynamic memory allocation where it stands for memory allocation. So this will dynamically create a memory of the struct pointer type and size of the struct node. So the memory size will be whatever is the size of this structure node, which is this which I create. And when I say root pointer next is equal to null and root pointer data is equal to 18, then what happens? In my node which is created, now which is referred to by the term root, so this is my root, so this is root over here, and when I say root pointer next is null, so this is named as null, and root pointer data is equal to 18, so 18 stores over here, so this is my complete root node. This is how I create a single node in the beginning of a linked list. Now let's see how to create a node and add it at the end of our linked list. So it starts with a normal hash include stdio.h, hash include stdlib.h, node data pointer. This is a structure which is created. Int main, we are using two pointers, so they can be declared in a single line. I have declared it in two lines. Struct node pointer root, struct node pointer temp. Root is equal to malloc size of struct node. This is another way of declaring. Root is equal to next null, root pointer data is equal to 18, so this is the node which is created. And when I say temp is equal to root, so now this was pointed by root, now this will also be pointed by temp. So temp as well as root both point to this particular node. Now I have to add it in the end. Let's assume that I have this node which is already created and I need to add an element at the end. If temp is not equal to null, you will see that temp was pointing at the beginning, so this is the pointer of temp. If temp is not equal to null, I enter the loop and say while temp pointer next is not equal to null, I keep on traversing till the end of my node. This is known as a traversal. This code is stand for the traversal in the linked list. So temp pointer next is not equal to null. Now here if you see, is this pointer equal to null? No. So it says temp is equal to temp pointer next. So now my temp points over here. So this is my temp. It goes back into the loop, says temp pointer next not equal to null. This is not null over here. So I say temp is equal to temp pointer next. So my temp now points over here. And temp pointer next is not equal to null, but yes, my temp pointer link is null is equal to, sorry, temp pointer next is equal to null. So we come out of this loop and then we say temp pointer next is equal to malloc size of struct node. So this node which is created, and this will be pointed by temp, because this is my temp at present, this is my current temp, and I say temp pointer next, I create a node, so this will be pointing over here, and I say temp is equal to temp pointer next, so it is now pointing to it. So now this becomes my temp. If temp is equal to 0, it says print out of memory, else temp pointer, you see that in the previous slide I've put that this points over here, so this is my temp. So temp pointer next is equal to null, so this becomes null, and temp pointer data is equal to 22, so this is added. Now this becomes my final linked list. This is how you add a node at the end of a linked list. Now let's see how do I print it, or how do I display the linked list. Displaying of linked list happens by traversing the linked list. So temp is equal to root, so this is my complete linked list. I say temp is equal to root, so this is my temp. If temp is not equal to 0, we start traversing. Temp pointer next is not equal to null, this is not equal to null, so printf %d temp pointer data. So what will be printed? 18 will be printed over here, and this temp is equal to temp pointer next, so it will come over here. And then you say temp pointer next is not equal to null. Yes, it is not equal to null, so printf temp pointer data. So what will be printed next is 20. Temp is equal to temp pointer next, so it comes over here. It says temp pointer next, so is it equal to null? No, temp is equal to temp pointer data, so what will be printed is 25, and temp is equal to temp pointer next, so it comes over here. So now it says while temp pointer next is not equal to null, but this is equal to null, So how do I print this data? So we say printf %d temp pointer x. Sorry, this is not x, this is temp pointer data. So when I say temp is equal to, sorry, when we say printf temp pointer data, so this will print 22 over here. This is how we print the complete linked list. Now we see what are the advantages and disadvantages of a linked list. Now advantages. The advantage of a singly linked list is an ability to expand to accept the virtually unlimited number of nodes in a fragmented memory environment. Linked lists are dynamic data structure, allocating the needed memory while the program is running. Insertion and deletion node operations are easily implemented in linked list, and linear data structures such as stacks and queues are easily executed with a linked list. They can reduce access time and may expand in real time without memory overhead. We release and acquire memory whenever we need to create a node. But with the advantages come few disadvantages too. So the disadvantages are its speed. Operations in a singly linked list are slow as it uses sequential search to locate a node. They have a tendency to use more memory due to pointers requiring extra storage space. Nodes in a linked list must be read in order from the beginning, as the linked lists are inherently sequential access. We cannot start reading from the middle, we have to start from the beginning to the end. Nodes are stored in continuously, greatly increasing the time required to access individual elements within the list. Difficulties arise in linked list when it comes to reverse traversing. For instance, singly linked lists are cumbersome to navigate backwards, and while doubly linked lists are somewhat easier to read, memory is wasted in allocating space for a back pointer. Now, in the further videos that will be following, we will see how singly linked lists are used to insert an element in the middle, to delete an element from the middle, and how the doubly linked lists, the circular linked lists are implemented, and also how queues are implemented using linked list. For the complete program of implementing a singly linked list, you can refer to the website anuradhabhatia.com notes section for the data structure linked list chapter. Thank you.